Hi, everyone. Just wanted to take a minute to talk about how to prove lines are parallel using some of the angle properties that we talked about last time in regards to transversals. So, if you recall, what we had talked about in the past was if I have two lines that are parallel, and I'll denote those like that with little arrows, and they're cut by a transversal, we have different angle properties, right? We knew that corresponding were congruent, and we knew that alternate interior were congruent, and alternate exterior were congruent. Finally, then the consecutive or same side interior / exterior, either or, were supplementary. So as a reminder, they added up to 180 degrees. So that's what we had talked about last week when we were dealing with transversal problems and parallel lines. However, this week we're going to be dealing essentially with the opposite this time. We are now going to be dealing with the converses of those different properties. And by that, we mean, before we were saying if the lines are parallel, then the corresponding angles are congruent. Now we're saying if the corresponding angles are congruent, then they are parallel. Same thing with alternate interior angles. The converse is saying if the alternate interior angles are congruent, then the lines are parallel. So we can go all the way down for all of these converses will apply. So now our goal, as opposed to saying, well, what's the measure of the angle? Our goal now is saying, okay, well, based on the measure of the angle, are they parallel? That's our goal here. So we specifically are going to use corresponding angles converse, which, as we said, if the corresponding angles are congruent, so as again, the corresponding angles, they were kind of in the same spot, right? If those were congruent, it's parallel. Alternate interior, remember that would be, like this one and that one. Put that in green. Alternate interior angles. Those are congruent, then they're parallel. Alternate exterior. These are going to be congruent. I should be using different amounts of lines. If these are congruent, then they're parallel. And then the final one we're going to talk about would be the same side or the consecutive interior. So, this one and that one. If these two add up to 180, the green and the red here, then they're parallel. All right. So that's our goal on this one. And then we do have one final property that we can relate to, which is saying if two lines are parallel to the same line, then they're parallel to each other. And all that that's saying is, let's say this line, I have line L, M, N. So I have these three lines, and I'm told that L is parallel to M. And I'm also told that M is parallel to N. L is parallel to M, and N is parallel to M. So therefore, L is also parallel to N. That's all that they're saying. It is if this one's parallel to this one, and this one's parallel to this one, this one's parallel to that one. So that's all that that's saying. So let's go through and figure out what the heck we can actually do with problems like this. So, for example, let's look at some different lines and angles on this one. So we're told that angle 1, right here, we are told that it is congruent to angle 9. So we're told that these two are congruent. Just looking at these two, if we kind of ignored this bottom part down here, right? Like if we just ignored this, we would essentially have a situation where this line is a transversal, and these two lines are cut by it. G and F. I should be using names here. G, F, and D. All right, so if these two lines, they're cut by, line AD, I should say. I missed the other point. But we're given that these two angles are congruent. So therefore, by the corresponding angles converse, we know that GH and line EF must be parallel. So we can conclude that GH is parallel to FE. And that just comes from the fact that we're told that these corresponding angles are congruent. Because we know that they're congruent by the converse, we can say that these two lines are parallel. The toughest part about this is going to be identifying which lines you can say are parallel. So I just realized I got rid of all of that. So let me just say GH, once again, is parallel to FE. All right. Next one, we're told that 11 and 14 are congruent here. Now, if we look in between AD and CB, we can see these two angles are both in between them. And they both are relating to line, they're both formed by GH cutting through AD and BC, these lines. So therefore, we do have two lines, AD and BC, that are cut by a transversal, GH, and it creates angles 11 and 14 that are congruent. By the way, I just realized this notation is wrong. It should just be saying that angle 1 is congruent to angle 9, and 11 is congruent to 14. We don't need the M. The M deals with measure. So let me just get rid of those. Okay, so we're going to ignore the M. Serves me right for copying and pasting. It's my own fault, but that's okay. So we're told that 11 and 14 are congruent. And because of that, we know just based on what we went over that they are alternate interior angles. And because they are alternate interior angles, we can conclude that line AD is parallel to line BC because of the alternate interior angles converse. So we can say that line AD, is parallel to line BC by the alternate interior angles converse. Okay, I'm going to erase that over here. Next one, let's look at the next problem. Let's use a different color. All right, so we're told that 3 and 8 are congruent. Once again, 3 and 8 are between line AD and line BC. And this time, though, they are formed by a different transversal. They're formed by transversal FE, line FE here. However, we still can conclude the same thing, right? They're still alternate interior angles. They are congruent, and therefore, by the alternate interior angles converse, we can say that these two lines are congruent. So we can still conclude that line AD, is congruent. I'm sorry, it's parallel, not congruent. That's my own fault. It's parallel to line BC. All right, so we are saying that they are parallel. And I misspoke earlier when I said that the two lines were congruent. I meant to say that they are parallel. So they are parallel by the alternate interior angles converse. And finally, we are told 15 and 9. Now, since we are told that 15 and 9 are congruent, they are outside of AD and BC, but they are still formed by the transversal GH. So we can say by the alternate exterior, these are exterior angles, sorry, by the alternate exterior angles converse, that these two are congruent, okay? So we can say based on that, lines, again, AD is parallel, to line BC. And it is cut again by transversal GH. I think this is very important for us to be aware of. I mean, obviously, these problems do not inherently relate to each other. For instance, just because up here angle 11 was congruent to angle 14 doesn't necessarily mean in this problem angle 11 was still congruent to angle 14. However, we could have ultimately gotten that result once we learned that they are parallel, right? Because then once we know they're parallel, we can go on and use, because they're parallel, alternate interior angles are congruent. Same side interior angles are supplementary, and so on and so forth. The one thing I do want you to be wary of is, let's say I gave you a situation such as, saying that angle 9 was congruent to angle 6. Right, so if we try and look at these, the two angles, the two lines that they seem to be relating to would obviously, well, there's really not any one particular thing. We're not really seeing any alternate interior angles here. We're not seeing alternate exterior angles. We're not saying anything about the same side interior. It's very hard to make any sort of judgments based on this. At this point, we really can't do anything with this information, right? We could potentially try and figure it out using linear pairs and vertical angles and things like that. But at this point, I can't directly say anything about these lines yet, all right? I need to do more work. So if you're not directly given a set of alternate interior angles or a set of alternate exterior angles or corresponding angles or something like that, you are ultimately going to have to do a little bit more work and figure out some different things that you could do. All right, last thing I want to show you is in this situation, and this is another situation you could encounter, we're not directly told if they are parallel. The problem for something like this would say, find x. So line TP is parallel to line WC. That would be a type of problem that you could encounter as well. And so it's telling you that we don't know if they're parallel, but if they were parallel, what would x be? And so we have to ask ourselves, okay, so if these were parallel, these two lines right here, these two would have to be same side interior angles, which would mean they'd have to add up to 180 degrees, okay? So they would have to be supplementary, so I would have to add them together. $180. Okay, we add them together, we would get 17x plus 27 equals 180. Now, when we subtract the 27, we get 17x equals 153. Now, you would divide by 17 here. And for simplicity's sake and for the sake of me making sure I get this right, when you plug that into a calculator, or you could do it out, x would ultimately be 9. So for x equals to 9, these two lines would be parallel, all right? If x was not 9, it would not be parallel because the two same side interior angles would not be supplementary. Okay, so I hope that helps. Please let me know if you have any additional questions, and I look forward to proving more lines parallel.